Hi everyone, this is R. Ranjit Kumar, Assistant Professor, Department of Mechanical Engineering, St.JOSEPH'S Institute of Technology. Today we are available in the lab called as MECHATRONICS with the lab code of ME3781. This lab is actually introduced for the students in order to understand the complex nature of creating a robot, which is having a multidisciplinary activity like coming together of computer science, mechanical engineering, electrical engineering, electronics engineering, and then control systems, etc. etc. This lab gives students a basic knowledge about how to develop a robotic structure. Mainly this lab incorporates like sensor and then actuators and then control systems and then microprocessor, microcontroller, etc., putting together and bringing out a new system which can be implemented into the real world, which can work as per the requirement of the customer. So this lab consists of various amount of experiments. Today in this class we are going to see two number of experiments. One is like the first experiment that we are going to see is verification of logic gates. As we are going to verify two logic gates, one is AND, another one is OR gate, which is going to be used in using 3x2 pilot operated wire. And single acting cylinder. And the second experiment that we are going to see is actuation of double acting cylinder using 5x2 pilot operated. So this is the two experiments that we are going to see in this lab today. Coming to the brief note about the mechatronics components, like this lab gives you detailed information about the sensors along with the actuators that we are going to see. The actuators are the important part that is going to actuate the movement of the robots. The actuators can be run with the help of both pneumatic and as well as hydraulic. As we all know that pneumatic is operated with the help of air and then hydraulic is actuated with the help of oil. So whenever there is a huge structure, we go in terms of hydraulics, and then whenever we are going to lighter structure, we are going to lift a lighter structure or going to move a lighter structure, then that is where we are going to use the air as a medium and pneumatic system as a main feature. So today in this class we are going to see these two experiments that is going to use pneumatic as a basic system and it is going to operate. So we are going to use the air and pneumatic system and we are going to see how we are going to actuate. So for that I have chosen two experiments. One is verification of AND gate and OR gate, and the next one is the actuation of double acting cylinder using 5x2 pilot operated valve. To continue with the experiment, the first experiment that we are going to see is verification of logic gates, that is AND gate and OR gate, using 3x2 pilot operated valve and then single acting cylinder. So this is the kit that we are going to use today in order to conduct this experiment. This kit is basic pneumatic trainer kit, which consists of number of valves and cylinders. I'm going to explain the important valves and cylinders that we are going to utilize for conducting this experiment. To start with, this basic pneumatic trainer kit consists of FRL unit. This FRL unit is it is used for like cleaning the air that we are going to get it from the atmosphere. So F stands for filter, R stands for regulator, and then L stands for lubricator. We are going to suck the air from the atmosphere with the help of this compressor that is available here. This compressor will suck the air from the atmosphere and it will compress it and it will send to the system with the required pressure, because we cannot use the atmospheric pressure and run the system, which is very less. It is not possible to move the actuator with the required action. So such that we are going to increase the pressure of the air that we are going to use it in the system. That is where this compressor is coming helpful. So compressor is going to suck the air from the atmosphere and it is going to compress and send it to the FRL unit. So as the incoming air consists of dust particles, the air is filtered first and then it is regulated, because the compressor sends the pressure at a high level, because we cannot use it to the maximum and we cannot use it to the very minimal value. We have to maintain the range of pressure. So that is where this regulator comes into action. So regulator regulates the air that is coming inside. It regulates the pressure of the air that is coming inside, and it's useful for the system. And then the atmospheric air that we are going to suck in is going to be a very dry kind of nature. So we cannot use a dry kind of nature of air into the system, which can spoil the component that is available, internal parts of the component. Because these components and valves are very delicate structures which can possibly get ruined inside by this dry nature of the air, because of the friction that is going to happen because of the dry air. So what we are going to do is, we are going to do the third thing called as lubrication. Lubrication is, we have the automized, we have an oil that is available inside this FRL unit that is going to be sprayed in a atomized nature. So that is going to mix with the air and it is sent to the system such that the internal parts of the components is not ruined, it is getting lubricated. So this is the main unit through which the air is sent to the entire system. So we have to maintain this unit properly in order to filter, regulator and lubricate. And then next, if you come in to this is called as manifold. So manifold is a unit where it is going to send the air to different part of the system. It is going to split the air to different parts, because we get only one output from the FRL unit, which is not possible to entirely actuate this entire system. So what we are going to do is, we are going to take this output from the FRL unit, and when there is a multiple number of input required, that is where this manifold comes into action. So it has multiple number of ports. We can straight away connect this FRL unit to this manifold entrance, and then we can get multiple number of output that can be used to the other parts of the system. Right. So this experiment again requires one more valve called as 3x2 pilot operated valve. That is nothing but the push button valve. This 3x2 panel mounted valve, that is push button, which has the valve that is mounted at the back side. These are all the two 3x2 push button valve which has already connected in nature. So this is where we are going to use this 3x2 valve in order to actuate the entire system of this verification of logic gates, AND gate and OR gate. So when I am going to start the experiment, I will detailedly explain how it is going to work. And now this push button valve has an input and then output. And then coming to the actuation of AND gate and OR gate, As we all know that AND gate logic, everybody knows that there is a truth table. So we have two inputs. So we have four logics. So there is 0 0, 1 0, 0 1, 1 1. So AND gate logic is that when there is only two inputs, that is where you get the output. For other all, you don't get any output. Even if you have one input, that is, if you don't have two inputs, you are not going to get any output. If you are going to get one input, you are not going to get any output. That is, again, if you are going to get another input from another section, you are not going to get the output. Only when two inputs are available, that is where you are going to get the output. So this is the logic that we are going to utilize in this push button valve. We have the two push button valve available here, the green one and the red one. We can consider this to be A and this to be B, and using these two input valves, we are going to execute this AND gate. So we cannot straight away use this 3 by 2 push button valve in order to execute the system. We need another gateway called as dual pressure valve. So this is the dual pressure valve. Why it is called as dual pressure valve is, it only sends the output when it gets both the inputs. That is why it got the name dual pressure. It has to get dual pressure in order to get actuated. So the input that is the output that is coming from this push button valve is fed to this dual pressure valve. If only both the inputs are available, it sends the air outside. So I keep on talking about this 3 by 2 valve, and everybody would have a doubt about what is 3 by 2. So 3 by 2 is 3 ports and then 2 positions. So always the numerator indicates the ports, number of ports, and the denominator indicates the number of positions. So that is why this is called as 3 by 2 port. And then coming to the experiment, let us start connecting the pipes in order to actuate this system. So now the compressor is straight away connected to the FRL unit. So it is directly connected to the FRL unit through which we are going to give the supply to the entire system. Now I am going to connect this. Make the connection, circuit connection. So we are going to get one output from the FRL unit, which is going to be given to the manifold. So I have connected to the manifold. These are all very simple connections. So you have to be very careful in connecting it. It should not be a loose connection because the pressure that we are going to feed in is approximately around 3 atmospheric pressure. That's why the air comes out at very fast rate. So if you have any loose connection, the pipe might get dismantled from the position. So that will cause some damage to the system. So we are supposed to be very careful in connecting the pipes. So I initially connected the pipe from the FRL unit to the manifold because we are going to get multiple number of outputs from the manifold. So now I am going to take one output from the manifold. I am going to take one output from the manifold and I am going to give it to the one push button, first push button valve. So I am going to give the push button valve inlet. I am going to take the air supply and giving it to the first push button valve. And now I am going to take this outlet from this first push button valve and I am going to give it to the dual pressure valve inlet. The dual pressure valve has two inlets, 1 and 2. I have utilized the first inlet from the output of this push button valve. Now I am going to take another supply. I am going to take another supply from the manifold and I am going to give it to the next push button valve. So second push button valve's inlet I have given the supply, air supply, and then the outlet from the second push button valve is going to be fed to the second inlet of the dual pressure valve. Now I have done the connection for the push button valve with respect to the dual pressure valve. So now both are got synchronized, like the connection is made. So once we give the air supply, whenever we are going to utilize this push button valve, it is going to send the air to this dual pressure valve. When I am going to press this 3x2 valve push button, first push button, it will send the air to the dual pressure. When I am going to press individually, if I am going to press individually, it is going to send the air individually. But what is required is, we are supposed to get both the inputs at the same time in order to activate the system. Now we are going to make the connection for the cylinder. So what is this? Very simple is that the output from the dual pressure valve is going to actuate your cylinder. The output from the dual pressure valve is going to actuate the cylinder. So cylinder's input is given here. So cylinders, this is a single acting cylinder. Why it is called a single acting cylinder is that once the cylinder gets the forward stroke with the help of the air pressure that is supplied inside, the return stroke automatically done with the help of the spring that is available inside. So there is a spring that is available inside that is going to get compressed by the action of the air that is supplied at one end. When the air supply stops, the spring retracts and brings back the piston to its original position. That is why it is called a single acting cylinder. Now we have made the entire connection and check whether the manifold's other ports are completely locked. If it is not locked, it will create a chaos. So one of the manifold opening is left empty, so that has to be closed with the knob. So now the entire system is completely packed, there is no leakage available. So now once again I am going to explain the condition, like we are going to get the input from the FRL unit to the manifold, there is output from the FRL unit to the manifold. Initially the input comes from the compressor to the FRL unit, the FRL unit to the manifold. So we are taking two inputs. One input is going to first push button valve, second input is going to the second push button valve. Push button valve got the inputs. Now the push button valve have to send the outputs. Both the outputs from the push button valve is given to the dual pressure valve. So dual pressure valve has the two inputs and one output. The one output is coming to the single acting cylinder. Now the single acting cylinder is going to get actuated with the help of the pressure that is going to be given. Right? Now the entire system is completely locked and we are going to actuate the process. So we are going to on the compressor. The compressor has to be initially started. Now the knob is turned on. The compressor is supplying the air now. So if you look at this FRL unit, you have a knob here, blue color knob. It is like a sliding knob. You can slide it forward and slide it backward in order to give the supply. So when you slide it forward, the air is supplied into the system and you can check the pressure gauge. When you slide it forward, the pressure gauge is getting engaged because the air supply is given to the system. When you slide it backward, the entire system is gets stopped and the air supply getting stopped. Now I am going to give the supply. The air is going to be supplied. So the system is really actuated. Now we are going to verify the truth table. As you see that we are having a truth table of both the input 0. I am not going to give any input. I am going to simply stand here. The piston is not going to get actuated. Now the second is I am going to give input for first push button valve. If you can see that the piston is not getting actuated. The piston is not moving. The piston is not moving. I am pressing it, the piston is not moving. I am leaving the second push button valve without any actuation. Now I am pressing the second push button valve and leaving the first push button valve empty. Again the system is not getting actuated, the cylinder is not moving. Now if you look at the fourth condition, we are going to give both the inputs such that the push button valve, both the push button valve has to be simultaneously pressed in order to actuate the cylinder. See, if I am going to press both the push button valve, my piston is getting actuated. The forward motion is because of the air supply that is given, and the return stroke is because of the spring that is available. When I remove the hand from this push button valve, automatically the piston gets retracted because of the spring that is available in the system. Once again look at it, I am pressing both the push button valve, my piston is getting actuated. When I remove my fingers from the push button valve, the cylinder retracts automatically. Now we can slide this knob and stop the air supply. We have seen the dual pressure, that is AND gate. Now we are going to see the OR gate. So everybody knows that OR gate is, so OR gate truth table, again we will go for this. There are 4 conditions available. So we will keep A and B, 2 supplied. So OR gate is like, you will not get any output for 0 actuation, and if any one of the input is there, your system gets actuated. Again, if one input is not available, another input is available, again the system gets actuated. When both the inputs are available, again the system gets actuated. So this is the OR gate, this is the AND gate, and this is the OR gate. OR gate, with the help of the name itself, you can identify that either or the input is available, the system is going to get actuated. So if A is available, B is not available, system is getting actuated. A is not available, B is available, system is going to get actuated. Both the thing is available, obviously the system is going to get actuated. So this is what we are going to see now here. I am going to change the supply here entirely to this shuttle valve. I have explained it about the dual pressure valve that is used for AND gate. There is one more valve called a shuttle valve. This is used for OR gate. Why the name shuttle valve is it shuts off when there is no supply. When there is no supply, this valve gets shut off. So that is why it is called as a shuttle valve. So what I am going to do is, I am going to entirely change the supply. I am simply going to transfer the supply to the shuttle valve. I am not going to make any changes. So I am going to remove this connection and I am going to transfer it here, and I am going to remove the second input and I am going to transfer. So removal of this pipe is simply easy. When it is not done in a proper way, it is getting complicated. So there is a spring type of knob is available that has to be pressed backwards in order to remove the pipe. That is where it gives you easy condition to remove the pipe. So now the pipe is transferred here to the shuttle valve. The entire system is now transferred to the OR gate. Now we are going to execute the OR gate. So OR gate, as we know that the truth table is 0 0, we don't get anything. 1 0 we get actuated, 0 1 actuated, both the things actuated. Now we are going to see, I am not doing anything. Now the push buttons are not pushed, it is 0 0. Now I am going to use only one, first initially we have to give the supply. So FRL unit I have switched on. Now I am going to press only one single input. Now the piston is getting actuated. We can see that I am pushing one push button valve, my system is getting actuated. I am leaving the second one empty. I am pressing only one, you can see very clearly my piston is getting actuated. I am leaving this green push button valve and doing it with the red push button valve. Again the system is. So in between the experimentation we faced a common error of pressure drop. the supply from the compressor is not proper in order to actuate the system. So we have refurbished the compressor activity. We got the pressure full now, and then now we are going to actuate the system. So once again I will refresh the condition like as you know that the OR gate, both the inputs is not available, you are not going to get the output. When there is one input available, you are going to get the output. When the input 2 is available, input 1 is not available, we are going to get the output. And when both the inputs are available, we are going to get the output. So that I will explain once again. Now the pressure is fully made. I am going to slide in the input from the FRL unit. So now, if I am going to give, if I am not going to give both the inputs, the system is not getting actuated. If I am going to give the input 1, the system is getting actuated, leaving the input second empty. Now the input second is pressed, the system is actuated, leaving the input 1. That is push button 1 is not given, push button 2 is given. And then the fourth condition is both the inputs to be on in order to get the output. So I am going to press both the inputs simultaneously. Now the system is getting actuated. You can view it closely like both the inputs are pressed in order to get the piston actuated. As I told you earlier that the system, this is a single acting cylinder, it consists of the spring inside. How it is getting retracted automatically backwards, student might wonder because the system consists of a spring inside, right? I am going to draw it on the board. You can see it clearly, right? We have a piston. So there is a cylinder available, right? So we are going to give input this direction, this side. There is a spring available on this side. Spring available this side. So this spring is free in nature when the piston is in a open condition. So when I am going to give the air supply, the piston is going to go forward such that it is going to compress the spring. When I am going to stop the supply, stop the air supply, the spring is automatically going to be relaxed, pushing the piston backwards. So this is how the piston is getting forwarded, getting the forward stroke and the return stroke. So to brush up the entire activity that we have done in this particular experiment. So what is that we have done is the verification of logic gates, AND gate and OR gate using 3x2 pilot operator bar. So I will brush up quickly. Initially the system was connected, the compressor was connected to the FRL unit. The FRL unit, the supply is given to the manifold. We took two outputs from the manifold and gave it to the push button valve's input. And then we got two outputs from the push button valve and gave it to the dual pressure valve's input, and got a single output from the dual pressure valve and given it to the single acting cylinder. So proving the AND gates logic, that is only when both the inputs are available the system was actuated. We have clearly seen that. And then once again we have transferred that connection to the shuttle valve. So shuttle valve where even a single input is available, the system is going to get actuated. That is the concept of the shuttle valve. Whereas the dual pressure valve, both the inputs are supposed to be given in order to actuate the piston. So this also we have clearly seen, verified that OR gate is also proven. That is only when single input is given, the system got actuated. So this experiment proves that AND gate and OR gate we have verified using a 3x2 pilot operated valve and a single acting cylinder. So next experiment that we are going to see is actuation of double acting cylinder using pilot operated valve. So I am going to dismantle everything now. This entire connection I am going to dismantle it, and then I will come back with the setup for explaining the second experiment. That is your actuation of double acting cylinder using 5x2 pilot operated valve. I will explain each and every component that we are going to use for the second experiment initially. and the nature of the valve, everything, etc. etc. And then I will start with the connection and I will show you how it is actuated. Moreover, this is called as automatic actuation. Automatic actuation of double acting cylinder using 5x2 pilot operated valve. So after the connection is made, when you give the input, the double acting cylinder is going to automatically actuate until unless we are going to stop the entire system. That is what is going to happen now. So that is the thing I am going to show it to the second experiment. So I will dismantle everything now and I will come back with the second experiment in a while. Thank you.